All right, new pilots, I hope you're all doing absolutely fine. Let's get started with ice and rain protection. So this is not going to be a very big lecture because this is a very small and puchu puchu kind of chapter, and there's not much that is going to ask in the exam. So let's start with ice and rain protection. Firstly, we have icing. So icing occurs at temperature between 0 degrees Celsius to minus 40 degrees Celsius, right? So this is the range in which you will face icing. After minus 40 degrees Celsius, no icing. All right. So this is the range from your 0 degrees Celsius till your minus 40 degrees Celsius. So in this range, what happens is there is something known as super cool water droplets, right? So supercooled water droplets are water droplets which are in liquid state and their temperature is below 0 degrees Celsius. Yes, you must have been taught till now that water freezes at 0 degrees Celsius, right? Turns into solid. But there are certain scenarios in which the water does not have anything to stick on and hence it stays in the liquid state, right? Even below 0 degrees Celsius, right? Till you are what minus 40 degrees Celsius, there will be what super cool water droplets, right? And after minus 40, the water starts to freeze. And when the water freezes, for example, let's say around 50 degrees Celsius, minus 50 degrees Celsius, the water will be in solid state. So this solid water, when it will touch our wing surface, it won't stick, right? But if we have our super cool water droplets, which are at liquid state and their temperature is like, let's say, minus 30 degrees Celsius something, so they'll stick to the surface, right? So that is why icing occurs from your 0 degrees Celsius to your minus 40 degrees Celsius due to the presence of supercooled water droplets. So we'll see what supercooled water droplets are. As I have already told you, that water is at liquid temperature below 0 degrees Celsius is called as supercooled water droplets, right? And they are liquid because they don't have any surface to stick on, right? In the atmosphere, uh, the water droplets, they didn't have anything to stick on, right? So they were liquid. But as your aircraft it came in and all of those water molecules, they just found a surface and they stick onto the surface. You'll see in this video that this is your super cool drop, and as you drop a surface in it, you see how the water starts to stick on it and forms ice, right? So this is super cool water drop, and let's go. So there are two methods, anti-icing and de-icing, and it is very, very important for you to know the difference between these two because these will be the terms that will be used very, very often, right? So what is de-icing? De-icing means ice is allowed to form and then it is removed, right? So if there is ice on your aircraft, it has already formed, and then you use some method to remove it. This is known as what de-icing, as the name suggests, right? De-icing. And anti-icing, as the name again suggests, anti, which means that the ice is not allowed to form, right? So, for example, if you have a surface and I'm keeping something like I'm trying to heat this surface, I'm keeping this surface hot. So there is no ice forming on it, right? And if I have a surface and I let ice form on it, and then I take the surface and I dip it into some kind of liquid so that it removes the ice, right? So this is known as de-icing. And this method, which is I'm constantly heating something so that ice never forms in the first place, is known as your anti-icing. All right. So there are three methods for ice protection. Firstly, there is mechanical ice protection, and then we have thermal ice protection, and then liquid ice protection. So we'll go in details of all three of them. Firstly, mechanical ice protection. So in mechanical ice protection, we use something known as de-icing rubber boots. So what are these de-icing rubber boots? So they are a de-icing system, as the name suggests, right? So which means what? They let ice form firstly, and then they'll remove ice, right? And then these are boots made up of rubberized fabric and pneumatic tubes are fitted under these fabrics. So you see this video, you'll know what pneumatic rubber boots are. So as you can see, these things they are inflated, right? So there is air that is going into these boots. This is your wings leading edge, by the way. So this, and now the air will be sucked out. Wait, I see the air is gone now, right? So this is your pneumatic rubber boots. They are fitted on your wing leading edge, right? And they are made up of your rubberized fabric. So this black color thing that you're seeing is your rubberized fabric, and these lines are because there are tubes fitted in it, which are filled with air. So there are pneumatic air tubes, right? So the tubes are inflated and deflated continuously, as you just saw, right? And the system is off suction pressure. Yeah. So if the system is off, right? So if I do not want to use my de-icing system because, for example, there is no ice, right? So I'll keep this thing turned off and I'll keep the suction pressure on, which means what? I'll I'll make sure that my boots are always deflated, right? Because if they're in this condition, as you can see right now, what will happen? They'll create a lot of drag, right? The wing surface not very smooth, so they'll create a lot of drag, right? So when I'm not using it, I'll keep it in a deflated position, or I'll constantly keep a suction pressure on it, which will keep them in a deflated position to avoid drag, right? So these are your pneumatic rubber boots. But there are some disadvantages for these boots. What are they? Firstly, they increase drag. Obviously, constantly they are coming in the airflow and they are creating restrictions, right? Obviously, as we saw the boots, right? So they are creating drag. First of all, this is one disadvantage. Secondly, they require a lot of maintenance because the boots wear out quickly, right? The boots, they're constantly inflating and deflating, so they can wear out very easily and they need constant maintenance, right? This is also one disadvantage. So these are the disadvantages of your pneumatic rubber boots. Next method that we have is thermal ice protection. And thermal ice protection itself can be done by three methods. So there are three methods for thermal ice protection. Firstly, we have by using hot air, which can be taken from the compressor, as you might remember from the pneumatics chapter, that we used to take our low pressure air from here, we used to take our high pressure air from here, right? Low pressure goes from here, the high pressure goes from here, and we used to use them, right? It used to go in your what do you call it, bleed air manifold, right? So in that bleed air manifold, we connect one service for our thermalized protection, right? So by using hot air from the compressor, second method is by using hot oil. Yes, so we are using engine oil in this process. And the third one is by using electricity. Let's see each one of them one by one. Firstly, by using hot air. So the most common type of thermal ice protection method is by using hot air. So your most modern aircraft will be using what kind of method? Your hot air method, right? And it uses hot bleed air from the engine compressors, as I already told you. And this hot air passes through the piccolo tubes in the wing. So there are piccolo tubes, basically, as you can see in this diagram. There are these tubes, right? There are these tubes that are running in the aircraft body from left to right, right? And the air from the engine compressor is spread with the help of these tubes. And these tubes have holes in them. So there will be holes in these tubes and they'll spray the hot air on the wings, right? So they'll spray the hot air on the wings leading edge, which will obviously remove the ice, right? So this is with the help of using your hot air, right? Then when we are using electricity, so with the help of electricity, how are you going to remove ice? So it is done by using high resistive wire. So wires, you might know, your coil kind of thing. So when your wire is having a higher resistance, when your current is having higher resistance, like your wire is having higher resistance, the current find restrictions to flow, which creates what? Heating, right? So all of the geysers, the coils, and all of those things, they work by this principle only, right? By creating resistance so that the wire heats up, right? So this is also using the same method and only used in small elements like petard head, angle of attack sensor, probe, temperature probe, and obviously because of the large current consumption, so they are not a widely used thing. You use it for your small components, like for example, your petard head or your angle of attack sensor. So these are like small components that need to be kept free of ice all the time. So you always use what? Your electricity kind of system. Uh, because it consumes a lot of current. That's why I don't use it for larger components. So there's not much in that, just a brief, obviously. Then your third method is by using oil. So hot engine oil is supplied throughout the aircraft body. And yes, so your engine oil, it is hot, obviously. And this hot oil is transferred to all of the different parts of the body. So the hot oil from the engine will be transferred to all of the different wires. You saw there were like pipelines and all, right? So the same thing will happen with the hot oil. Like earlier we saw was with a hot air. but the same tubes will be there for hot oil. But what happens is your oil is taken from the engines, right? So engine oil is very, very hot, and the engine oil needs to be cooled down, right? So by using this method, we are first of all removing the ice, and secondly, we are also able to cool down the engine oil. So this is like we have two advantages, right? We are just with the help of one process, right? But this is not very often used. Why? Because if there is any damage to the aircraft body, it can lead to the loss of engine oil. Obviously, if I have any puncture or any bird strike or something happening to any part of the body, it might create a leakage, right? So the engine oil, it will flow out of that part, right? So that is why it is not very often used, because the engine oil might just flow out, and loss of engine oil is very dangerous thing, right? Even in cars, you might have seen if their engine oil is low, then it is considered to be critical, right? So this is your thermal ice protection done. We have seen with air, with oil, and with electricity. All right. Then we have fluid ice protection. So in fluid ice protection, we use glycol-based fluids, right? So glycol-based fluids are used for your ice protection, and it works both as de-icing and anti-icing. So see, what happens is you have a tank over here, and the tank, again, you have your pipelines which are connected to the whole aircraft body, and then there is fluid transferred throughout your body. So the fluid will be what your glycol fluid will be transferred through these pipelines and will be sprayed onto your wings. As you can see, a close up is shown here that there are holes, and through these holes, your liquid will be coming out, right? So it works as both anti-ice and de-icing, because see, if there is already ice that is formed on the wing, then what will happen? Because of this fluid, the ice will start to melt, right? And because this fluid will cover up the wing surface, right? It will cover up the wing surface. So there, if there are any super cool water droplets in the atmosphere, then these water droplets would not stick to the surface. They'll just flow out of this. So it is also not letting ice to further form, right? So it is working as both anti-icing and de-icing, right? So now we have windscreen ice protection. So windscreens, they have three different methods. They have your liquids, they have electricity, and they also have a rain repellents. So what are these liquids? So there are de-icing liquids that are used in windscreen, and they use what? Methyl-based alcohol. So methyl alcohol-based fluids are used for de-icing. Remember this thing? De-icing, what do you use? Methyl based alcohol in your windscreen, right? And your windscreen are also electrically heated, right? This is also important. Your windscreen are electrically heated, and the electrical heating not only helps in anti-icing and de-icing, but it also helps to resist the bird strikes, right? So electrical heating of the windscreen is kept on from takeoff till landing, since it makes it more resistive to bird strike, hence it becomes an anti-icing system, right? So right, what happens, you keep your anti-icing sorry, your electrically heating of the windscreen on from takeoff till landing, and it makes it more resistive to your bird strike, right? Because if you heat something, it becomes what? Flexible, right? So that is exactly what happens with your windscreen. So if there is some bird that hits the windscreen will be better able to absorb that shock, right? So that is why you keep it on from takeoff till landing. And if you keeping it on, which means what? You're constantly heating it, and this means what? That you are not letting ice to form. So it works as a anti-icing system, obviously, because you're not letting ice to form in the first place, right? And then there are rain repellent fluids that are also used in case of heavy rain. So rain repellent fluids will be sprayed on the aircraft. There is a button in the cockpit. You can just press that button, and then there will be fluid that will be sprayed on the windscreen. And what this fluid does is it makes water to stick together and form large droplets. So these large droplets will do what? They are heavy, so they'll just fall down. Right. So this is what your rain repellent fluid is, right? And it is to be used only when it rains, right? If you try to use this fluid when it is not raining, then what will happen? It will reduce the visibility of the windscreen. It will stick onto your windscreen, it will reduce the visibility, right? If your windscreen is having overheating issue, then there will be something known as vinyl bubbling and discoloration. So you can see what vinyl bubbling looks like and what discoloration looks like. This will happen when you're having some malfunction in the heating system and your windscreen starts to overheat. And then there is propeller ice protection. So propeller, they only need ice protection in the inner section and in some aircraft in the middle section too. Right? Why? Because the outer section, if you know, is rotating at a faster speed. Obviously, because it has to cover a larger distance. So the speed will be faster. And if you compare it to the inner section, it will be rotating at a slower speed. Right? So this portion does not get ice. This portion does not get any ice. It does not need any ice protection system. But the middle section, this one, and your inner section, this one, they need ice protection system. So how are they protected with ice? The inner section or the middle section, they are fitted with heating elements, right? And these heating elements are known as overshoes, right? So these black colored thing that you're seeing on your wing inner section and the middle section are your known as your overshoes, right? And as you can see, this portion is left untouched, right? Why? Because obviously they are rotating at a faster speed, so the ice, because of the centrifugal forces, will be thrown apart, right? Very easily because they are rotating at a very, very high speed, right? But the inner section, they are thick and also they are rotating at a slower speed. That's why you need what? Your overshoes, right? And then there are cyclic timers. They are used to de-ice one engine blade at a time, which reduce power requirements. So they are just timers, right? That you fit what this timer does, they're cyclic timers, so they cycle and they de-ice one propeller first, and then they'll transfer the power to the next propeller. So this reduces the power consumption. That is all you need to know. Okay, so that is it for your de-icing and anti-icing. This was all that was there in your de-icing and anti-icing. I've covered everything from Oxford. So that is all that was there, right? And one more thing, guys. If you want to complete your principle of lights, if you want to complete your engines and electrics, then there is a link attached in the description. Just go and click on that link. You will be directed to a Google form. Fill that up. I'll contact you and we'll start from there. All right. Thank you. Bye bye.